Our next panelist brings a wealth of diverse experience to our discussion today. Currently serving as an application and infrastructure developer, he has spent a significant portion of his impressive 12 to 15 years in IT exploring a multitude of roles, ranging from intricacies of office system admin to the responsibilities of being the cybersecurity responsible for substantial enterprise platform. What sets him apart in this journey through a variety of work environments from NGOs to companies with weekly payrolls and large-scale enterprise boosting thousands of developers. Such a rich tapestry of experiences has undoubtedly shaped his perspective on the industry. His passions lie in the realms of testing, security, privacy, and software design. This unique blend of expertise and enthusiasm makes him a dynamic force within the IT landscape. Today, we have the privilege of tapping into his wealth of knowledge and experiences. Please join me in welcoming our esteemed panelist and an IT veteran with a broad spectrum of expertise, Aleksei. Over to you, Aleksei.
Thank you very much. Very nice introduction. Didn't expect that. Thank you.
Thank you.
So let me arrange my stuff here quickly. How do we gonna do this? Now the share button disappeared. This looks right. Can you see my screen?
Yes, yeah.
Nice. Let me find the chat and cool. Let's go. No, not let's go. Almost. Yeah, this is me, Aleksei. I was already introduced very well, so I won't be bothering you with this. So regarding the talk, if there are some questions in between, I will try to answer them. And also, if I don't spot them in the chat, dear facilitators, please interrupt me. This is completely fine. I'd rather take it a bit longer and explain things than have them unclear. So, and also give some feedback while I'm going if it's too fast or too slow, so I can adapt to the needs of the audience. What are we going to be talking about? So primarily we'll be talking about the IDORs, Insecure Direct Object References. This is vulnerability that happens when you have, essentially you have IDs in your URLs, so objects are globally addressable, and then someone can change those IDs and the authorization is not fulfilling its purpose and allowing users who shouldn't have access to get access to the underlying data. So in these examples below, you can see some API, and we can get a user providing its ID in the URL, or we can get a user orders providing also user ID and order ID in the URL. And in the first example, we can potentially forget to check if the user is allowed to access another user, right? So if I want to get my data for the front end, for example, to render the username, I might call this API, but the backend will not check if who is calling this API is actually user 120. Maybe this is a different user. And the second example, it could be a bit trickier here because we might check that the calling user has actually ID 120, but the order ID we can forget. And if an attacker replaces the order ID in this URL, then they can get essentially arbitrary order and fetch this data. Why are we talking about this? Because in 2021, OWASP organization brought broken access control to the first position in their list of the most common vulnerabilities. And this, well, it's since quite a while, this type of vulnerability is causing a lot of damage to multiple companies. And it's really, really easy to exploit, right? You could just go to the website and just try different IDs and see, okay, can I get something or not? And it's also easy to forget, right? This. So how to mitigate this? OWASP advice says you should implement access control checks for each project, or for each object, sorry, that users try to access. Cannot argue with this advice. Definitely should follow this, but I have problem with this advice because I think it's not very actionable. Why do I think so? Yes, because people forget. What if I just forgot? Right? And developers are people. Developers forget to check if the user authenticated, if data belongs to a different user when they're presenting it, or user has admin permission, so they don't. And I mean, there are plenty of reasons to forget this. Maybe you're in a hurry delivering a project, or PO doesn't consider security a priority and you didn't even discuss it. Maybe you inherited the project, don't know much about it, don't know much about the data and how to protect it, or maybe you just wrote this code ages ago and now you need to extend it and you just forgot everything that you did a year ago. So here I would like explore some options, some ideas, how you can utilize your language type system, how you can utilize your compiler to prevent these mistakes that can cost you your job potentially, or huge lawsuit to a company. So first, let's get inspired. By the way, the slide deck from now on will have a lot of code. I don't know if you would like it or not, so I would like to get some feedback. What do you think about having a lot of code in the slides? And also some disclaimer, the code will mostly be correct, but not always. It will mostly be oversimplified. Shouldn't follow it as it's presented here. It's mostly for expressing ideas to make them understandable and yeah, understandable. So let's look at some code here. So this is Rust. This is the only time we will be talking about Rust in this talk, so don't worry. I like Rust a lot, but I'm not advocating using it everywhere. It's a very special language, I would say. But this is a good example, and maybe we can get inspired with this and see where does it lead us. So essentially what it does, we have some array of data vector, we wrap it in the mutex, and what Rust as a language gives us, that once it's wrapped in the mutex, you cannot change it. There's almost no way to access the data without acquiring the lock. If you need to read it, you need to update it. Anyway, you won't be able. It's a compile time error. So how can we use this? Let's look at the first example. Some financial application in Java. We have some accounts and money can be withdrawn from these accounts. Something usual billing stuff, kind of, right? So we have some account, has ID and has some deposit amount, and we can withdraw some money, and we obviously should check if the account has enough money so we can withdraw it. And we have some account repository where we can get account by ID, modify it, and then save it. Something very common. Problem: we need to log the account. So we need to have some log, essentially, right? Because if there is some withdrawal URL that we provide in the API, then if I am quick enough in my console or browser, I can withdraw money twice and it won't be tracked, right? So I will potentially pay multiple orders or order multiple things without paying for them. So this is a security issue. So we need to lock the account first to ensure that only one change is happening to the account. We cannot withdraw it twice in the same at the same time. This code is maybe a bit unusual if you're used to working with SQL, but in this case, this is based on real life experience. We were using some NoSQL database. It didn't have logs as a feature, and so we had to essentially have an external locking service thing. So we would need to block the account first by the account ID, then try to get it. If account is there, then we withdraw some money, save the account, and then we have to release the lock. And the locking service looks very simple, something like this. So what problems do we see here? So it's easy to forget to lock. This method is already implemented, but if you implement another one that will be doing something a bit different, you might forget to acquire a lock. You might confuse the order, because the order matters in this case. If you acquire the lock after you get the account, maybe it's a bit, well, it's probably a bit too late, then the code won't be correct. You might forget to release the lock, or you will save the account after the lock was released. So all of those things essentially lead to incorrect behavior and will make our locking useless, more or less. So what we can do about it? Getting inspired by the previous example, what if we introduce another class, or we can use an interface here, locked account, right? We will introduce another method where we get account for modification, and then when we want to save it, we can only save the locked account, right? So this way we can ensure that whoever wants to save the account already took care of locking, right? And these methods, get for modification, will be acquiring the lock, and save will be releasing the lock, maybe, or maybe not. So we can also take care about the releasing the lock using auto-closable interface, having a close method, and then our code will be looking something like this. This code throws exception, but let's not worry about it. So we get account for modification, it returns locked account, and here we use this in Java. There's structured, it's called pattern try with resources. So as soon as we leave this try block, the close method on the locked account will be called automatically, and the lock will be released, right? So we get the locked account, we can access to underlying account here, and then we can save it. And our repository code, the real implementation, might be looking something like this. Because we had an interface, we now doing an implementation, different, bit of a parallel class hierarchy. So we have locked account, very specific for this repository. We only accepting my locked account. So if it's something else, we will throw an exception. If the account for some reason is not locked, or the lock was released, for example, we will throw an exception. So once we once we checked all of this, we can save the account. We have some private method, and what's important here is the my locked account is a private class. So here we have visibility restriction, which means that only it can only be created by this repository, right? No other code has access to this specific class, my locked account. And I didn't give the example here, but essentially the method that is get for modification will be creating this locked account and returning it. So then it can, the repository can have this kind of keep track of the logs, right? And when the account is closed, we can release the log for this account automatically. So to summarize, it's really hard to forget the log. If you try to pass the account there, obviously it's a compile time error. Locking fetching order controlled in the repository. You're acquiring the log when you fetch the account, you're releasing the log when you save the account, or when you use try with the resources, as in our example. Any linter will highlight that you forgot to use try with the resources on auto-closable. And repository checks if the log is still being held, right? So we created this robust structure that allows us to be sure that every time someone tries to modify the account and they will try to save them, the account was locked. What about authorization? We were talking about seemingly unrelated stuff. So let's look at another example. We have some single page application where user can log in, they can enter their payment data, order some voucher, no, doesn't matter what it is, see their orders, see their invoices. We need an API for the front end. Backend is implemented in Scala using Play framework. Using some identity provider with JSON Web Tokens. So what we can see here is all the data that user needs to deal with should be connected to the user ID. There's no other way. So the first, how it usually starts, there's always a person like this in the team. Let's do a proper RESTful API, right? And this is something what people consider RESTful API. Well, I mean, it is, but not only this, right? So we have URLs, we have users, then we put the user ID in the URL, and we can get this user data. We have orders, we can pass a query parameter user ID, we can get orders of this user. Another advice that WASP gives is avoid exposing identifiers in URLs or in input parameters. And this is what we can do here. This is the first step in our design process. We will be having this kind of URLs having my in the middle, get my identity, get my orders. And essentially already with this design, the only place where you can, when you want to fetch the identity, for example, the only place where you can get the user ID it's a token, right? There's just no other way here. And regarding the orders, I mean, in this case, you can potentially return all the orders in the system, right? Because you don't have anything. But yeah, essentially the ID is not exposed. So this is already good. And what else we can do? Remembering our previous examples, we can create service that gets the underlying service for our endpoints, right? We can get the user identity, we can get the orders, but as an input, we will be taking not just a user ID, but we call it authenticated user ID. And then in the authentication package, we have this authenticated user ID class defined, and we have some authenticator class. What it can do, well, essentially the only thing it can do, it can accept some token as a string, do the validation, do the parsing, and then extract the user ID from there and return it as authenticated user ID. What is important here is this part, private authentication. This is in Scala, you can control visibility like this, right? So it means that this class constructor is only visible within the package authentication, right? And authenticator is also in this package. So the only way you can create this authenticated user ID is by calling this method authenticate, which will do the actual validation of the token. And there is no way from the at compile time, there is no way to bypass it. I mean, this file probably won't be huge, right? And we can just open it and look, is there any other code that creates authenticated user ID if we are concerned. And then for our controller or routes, this is a bit different in Play framework, how you usually do it. This is how our API look. So we have some path prefix my, and after that we authenticate, we extract the token, validate the token, and provide the rest of the code with authenticated user ID if it exists, right? If we manage to extract it from the token. If the token is invalid, this code won't be executed at all. And then our services can just get this authenticated user ID and do whatever they need to do with it, right? Get the value, query the database, fetch all the resources. There is an issue with testing. When you have these rigid restrictions, how do you test the code? And there is one trick it works in JVM languages, right? You can have a test authenticator class in test directory in the respective package, right? So we will have the authentication package in the test directory as well, and there we will be able to access authenticated user ID. So in tests we can create something as simple as this to be able to create arbitrary authenticated user ID, or maybe even simpler. I don't know why I didn't put it here, but maybe this thing will just have like create authenticated user ID, we'll get user ID, and then just return this thing. And then we can test the rest of the code with this. So now we've designed the system in such a way that there's no possibility of getting user ID from a trusted source. Can only fetch it from the token. Even if some functionality gets added, we have the rest of the code is already in such a shape that you have to think about user authentication, right? Or at least it will be guiding you to. But what often happens when people onboard the project, they start copy pasting existing code because they don't know the project well enough to write it from scratch, and it's just also sometimes very convenient to copy paste some code and then modify it. And if you copy paste the existing code, you already mitigated this issue, right? You're already relying on this authenticated user ID, or at least you will get a reminder. But what if your use case is more complex? Let's say we have some Java application exposing API. We have multiple projects. Each project has some managers that track it and some customers assigned to it. And manager should only be able to see the project and customer data that belong to the project they're responsible for. And API looks like this, right? We have projects, project ID, customers, customer ID. Maybe this already exists. We cannot influence it, the API design. So what can we do here? So it's already prone to IDOR vulnerability because we have IDs, and code will evolve, endpoints, features will be added, and there is a risk of some data will be publicly available. Cool. And we might not have a feature-rich authorization framework in place, but we have certain business rules, right? We have that only the manager assigned to a project should be able to access the customer data. So what can we learn from the previous experience? What if we introduce a permission class capturing all the access rules, or probably multiple permission classes, right? In this case, we can use we can have some classes get customer permission get is like, am I allowed to get customers in this sense? And then we can potentially add it to the repository, maybe to the end place where the data will be coming from. And our repository can be doing something like this, right? Fetching the customer and then delegating it to permission to verify if I'm allowed to access the customer. Also, if we want to get all the customers for the project, the same way here. So this approach reaches two goals, essentially. It makes it easier to follow the rules than circumvent it, right? If you ever need to get the customers in the new functionality, you will probably think of how do I get this customer permission rather than implementing a new method in repository. And also the second goal is to establish patterns that remind everyone, even if you need to write a new method, you will look at the other methods, how they implement it. Okay, actually, I need to take care of the permissions here. And our controller code might be looking something like this. So we get a customer ID as an input, and validated access token will be provided to us by some by framework. It's important to note here that we can use the same visibility restrictions here, right? So the validated access token can only be created if it's really valid, right? We cannot create it otherwise with arbitrary data. And then token can also create the permissions, also with the same restriction that only if permissions do exist, the permissions can be created. And then to get the customer, we will pass it to the repository, and repository will be taking care of the verifying it. Another option, what we can do is also, or instead of maybe in your case the repository won't fit you, that adding permissions to repository won't fit you, but instead we want to check it when we return the customer data, right? It's often we have a set of DTOs, data transfer objects, that are getting reused across all the endpoints, and maybe that would be more convenient option. So we can make sure that the customer DTO is only created if the user is allowed to view this customer, right? We can assert that the permission is granted, and maybe some fields we have extra should have extra control on the data, right? And maybe managers shouldn't be able to see their phone number or maybe their real name, right? Maybe they are allowed to see their, I don't know, orders or number of invoices, I don't know, something, right? But some data might be restricted. So we can potentially do something like this, right? And in case if we have, in case of DTO are reused in the API, and we have also project DTO, which will contain a list of customers, this will also enforce permission check, even if we are fetching the same data from the different endpoint, right? We will still have to have some customer permission here, which might be derived from the project permission, right? If the manager has access to the project, therefore they have to have access to the customer. So maybe project permission might provide us with customer permission as well, limited to a certain number of customers maybe, or something like this. So there is some might be some concern about the violation of abstraction layers in the code structure when we use it in the repository, which might be fair or might not, depending on your domain, depending on how you decide you want to treat authorization in your application. If it's important enough to be a part of your domain, maybe not. Maybe then you can fall back to your DTOs checks, or maybe you can accept that the code will be a bit messy. What if this API used by another services is like, do we have machine-to-machine authentication or service-to-service authentication? Here we can do some abstraction. Maybe we have two different tokens. One token is for individual user, another token is for another system accessing our system. And but permissions might be derived from these tokens. And yeah, developers again often lazy and copy paste existing code to follow, and we'll just follow established patterns. If we I'm sorry, alarm. Yeah. So we've looked at several patterns, several ideas that can help us to not forget the check for the access. So it would be nice to if they all be rock solid, but anyway, I mean, developers can change any code and can modify it, and there is just no possibility making it rock solid. But it's important to remember that patterns tend to scale, right? The patterns that we establish in our code will be repeated over and over again because people are lazy. People just follow the. I'm not saying lazy is a bad thing. I'm lazy myself. It's just easier to do so, right? People will learn from these patterns, and these patterns can prevent our code base from changes that that will hurt our security posture. But they still imply some trust in your teammates doing the right thing. Yeah, I hope you got inspired and hope you will come up with something that will fit your use case. And with that said, thank you. Questions? I know there should be a cat in the slides, so there is a cat. I'm a professional here.
Alexa, there is one question.
Wait, there is one question. There is question.
Yeah, in the Q&A.
Would something like aspects Java also be helpful to execute something before function execution for checking permission? Well, yes, but you need to not forget to add this to the function, right? Depends on which level are you setting this up on. So if you're adding it to the repository, then probably it probably will be the same thing as here, right? You can also forget to add permission object to a repository method as an argument, and then you won't have this protection anymore. But if you're adding these aspects to the controller methods, right, you're this is your last resort kind of thing, right? You won't have it. So the controller methods tend to change more often than the repository ones. At least there usually are some generic repository methods that give you ability to fetch all the data, and they get reused over and over again in different places. So this can be a good fit, as well as the DTOs, right? They are getting reused often because why would you create a new customer structure in your API if you already have one? So, but I think, yeah, this could be an option. Is there any open source tool to check source code? Thanks. I'm not sure I understand what meant. I mean, there are plenty of open source tools to check the code. Speaking of the IDOR vulnerability, maybe there are some linters that or security scanners that might give you some hints, but this is such a vague thing. I think that is for me it would be even hard to understand how to approach this problem. And given the fact that there are plenty of those in the wild, I think it's not that easy to find them in the scanner. There are too many ways to get access to the same data, or might be too many ways to get access to the same data, different endpoints, different data structures, right?
Yeah, thank you, Aleksei. That was great.
You're welcome.